Let's continue on with some more examples. So the first example here, for two events A and B, it is known that we have the probability of A, the probability of B, and the union, and we want to find the intersection. So knowing these three, that fits in with the overlapping event. So I'm going to put an O for overlapping. So we're going to fill in those things. We know the union. The union is 0.50 is equal to the probability of A, 20, plus the probability of B, 0.40, and we want to subtract the probability of that intersection, which is what we are trying to find. So if we do some math here, that's 0.60 minus the probability of their intersections. And if I subtract, I get a -10. So the probability of A intersect B is about 10%. Alright, the event X and Y, we have the probability of X, we have an intersection, and we have the given, which is dependent, which is also a conditional probability. So remember, the conditional formula is the probability of, we could say, X given Y, or let's see, they said Y given X here. So of Y given X is equal to the probability of their intersection divided by the probability of X. Well, if you look at the dependent, events here, what they've done is they've just multiplied. They multiply both sides by px, so the probability of y given x times the probability of x is equal to the probability of their intersection. They just got rid of the fraction in that dependent sentence. So the formulas are the same, it's just going to be what can you remember and match up the most. Remember, the conditional probability is the formula that is actually on your EOC formula sheet. So I'm going to write dependent at the top since that's what's given to me. And I'm going to use, so we have the intersection. The intersection is 1/5. And that's going to equal 2/5 times the probability of y given x. Okay, I just wrote it in a different order here based on what I have. But so we undo multiplication with division. Okay, but we have fractions. So I'm going to choose to multiply by the reciprocal on both sides. So by 5/2 here, and by 5/2 over here. So this 5 and this 5 cancel, this 2 and this 2 cancel. And I have 5/10 is equal to the probability of y given x. So the probability of y given x is equal to 1/2. Remember, we always simplify our probabilities the most that we can. For two events B and C, it is known that we have a given, and then we have an intersection, and we want to find the probability of B. So we're going to use this same dependent event here. We know the intersection, so 0.48. That's going to equal the probability of B times the probability of C given B. So once again, we have multiplication. We undo multiplication with division. So we're going to take 0.48 and divide it by 0.61. And if we round to that nearest hundredth spot, the probability of B happening is a 79% chance. Alright, suppose that the probability of Eric coming to the party is 80% and the probability of Emma coming to the party is 95%. Assuming these events are independent, what is the probability they both come to the party? So if we want independent, because that's literally what they just told us we're looking for here, okay, let's write down what we have. If we're using independent, we want the probability of A and B equal to the probability of A times the probability of B. Well, we have, I'm going to use that formula, but let's look at what we have here. We have the probability of Eric, and that's 0.80. Remember, we don't use percentages, we use decimals in math. And the probability of Emma is 0.95. So we're going to say the probability of Eric and Emma is equal to 0.80 times 0.95. And that's a 76% chance of that happening. The probability of playing basketball is 12%, and the probability of playing both basketball and football is 5%. What is the probability of a person playing basketball given, or football given they play basketball? So let's write down some of the things that we have here so we can identify better. We have the probability of basketball is 12%, and the probability of playing both basketball and football is 5%. What is the probability of playing football given basketball? So that's one of those dependent ones, or the conditional probability, because we have that conditional statement there. So we have the probability of their intersection is equal to the probability of one event happening times the probability of the given event. So we're multiplying here, so we get to divide to solve. So we have 0.05 divided by 2. So the probability of football given basketball rounded to the nearest hundredth is 42%. Last example here. Joel and Rico are playing basketball. The probability that Joel makes a three-pointer is 64%. The probability that Rico makes a three-pointer is 85%. The probability of at least one of them making a three-pointer is 95.5%. What is the probability as a percent that both Joel and Rico will make a three-pointer? So let's write down what we have again. So the probability of Joel, 64%. Probability of Rico is 875. The probability of at least one. So the probability of Joel or Rico is 0.955. What is the probability as a percent that they both will? So Joel and Rico. So if we look at that, that is an overlapping event. So we're going to have or, okay? So they both have, so at least one of them happens. Then we have Rico plus Joel, and we have to subtract out their intersection. So 0.64 minus, plus 0.875. So this is 0.955 is equal to 1.515. So we'll subtract, and we get negative 0.56. So the probability of Joel and Rico is 56%. That concludes these examples. Okay. Tune into your homework practice, and please ask me questions on the reminder. Happy studying!